All right. Okay, so here basically what I want to do is I want to finish 1.1, which again is, what we're covering. Then what I'm going to do next is, then after that, we'll do a short worksheet on linear equations. And then after that, hopefully we'll start, if not today, then definitely Friday, we'll start section 1.2, which is quadratic equations. And that's actually going to be an application of factoring, as you'll see. All right. Okay, so anyway, here, this is this is a reminder of what we did last time, the least common multiple. Again, with linear equations and the ones we're going to see, there are going to be fractions in them. Numerators over denominators, right? What's going to happen is you're going to want to eliminate those denominators somehow. Now, one way to do that is to get the least common multiple of the denominators. And then what you're going to do is you'll see is you're going to multiply both sides by it, and then that will eliminate the denominators. I mean, what's nice about the least common multiple, you'll see when we actually solve these equations, is that it keeps the calculations from getting too crazy, mostly because the numbers don't get too complicated. And also in the end, I mean, it's not really going to be an issue for my class here, this class that is, but sometimes if you have to simplify your answer with the least common multiple, you'll have less simplifying to do. Okay, so again, this is just a reminder what multiples are. Although really 0, I guess I can throw out. I mean, it is part of the definition, but for what we're going to do, 0, we can really just disregard. Okay, and remember, for any two non-zero integers, the least common multiple, the LCM, it's the smallest positive integer that's a multiple of both m and n. Okay, again, it's a multiple of both m and n. And you could actually extend this definition to 3, maybe even 4. It's just, again, the smallest positive integer that's a multiple of all the integers involved. I mean, here we did it for 6 and 8. The best way to handle it in this class is to list the multiples. You keep going until you get something in both lists. So you would so for 6 and 8, you would list the multiples of 6, a bunch of them, list multiples of 8, and you keep on doing this until you get something in both lists. That would be the LCM, the smallest common element in both lists. So here we list a bunch of multiples for 6, which is 6, 12, 18, 24, 30, 36, and I just stopped at 48. For 8, we have 8, 16, 24, 32, 40, 24. 24 is in both lists, so 24 is the least common multiple, right? It's the first element in both lists. Same thing for 12 and 10. I mean, for 12, I listed a lot. For 10 and 12, I listed more elements. But you can see when I listed them, 60 appears in both lists. In fact, it's the first number in both lists. So 60 is the LCM. I mean, there's other common multiples like 120, but 60 is the least common multiple. Okay. Now let's actually find the LCM and use it, okay, to solve an equation. All right, so the LCM of 3, 4, and 6, okay? Well, for 6, let's list the multiples. We have 6, 12, 18, 24, 24. Did I make a mistake here? Well, 6, yeah, I listed some things that should not be there. We have 6, 12, 18, 24, 30, yeah, 27 should not be there. Let me just cross that out quickly. Okay. And, we listed a bunch of multiples and stuff, as you can see. Okay. Well, let's list some from 3. We have 3, 6, 9, 12, 15, 18. Okay, so we have 12 here, 12 here. Okay, well, that's in both lists. 6 is also. But now we want to list the elements, the multiples of 4, 4, 8, 12, 16, 20. Well, the smallest number in all 3 lists, right? The smallest multiple of 3, 4, and 6 we get is 12. So 12 is the least common multiple of 3, 4, and 6. All right, that's good. Again, how did we find that? I mean, really, based on what we know, you just have to list multiples of each number until you get something in all 3 lists, okay? I mean, we have 6 in 6 and 3, but 6 is not a multiple of 4, so that wouldn't work, but 12 works. All right. Now, okay, big deal. What do we do next? Well, we're going to multiply now both sides by 12. Remember, when you have an equation, there's only certain manipulations you can use to solve an equation, right? One of them is multiplying by the same non-zero number or dividing by it on both sides, right? We had those manipulations that you can use, and they work. They're the only ones you can use because the equations you get are equivalent. So this is equivalent to this one, meaning the solutions are the same. Okay. Now, okay, so what do we do here? Well, we are gonna distribute. Okay. Right, when we distribute, we get the equation below, right? We're just simplifying the left-hand side. That is something you can do. All right. So what do? Well, we're gonna do some algebra here, right? We have 3 and 12, right? Well, 12 over 3 is 4. So this cancels with, this is gone. The 3 is gone. The 12 becomes 4, like so. We have 12 times 2x, so, okay, no canceling there. 1 over 4 times 12, 4, yeah?
So when we distribute like the 12, we're only attacking the denominator. We're not going after the numerator.
We're not going after the numerator yet.
Okay, thank you, sorry.
Because we're trying to cancel some stuff, right? The whole point is you want to get rid of those denominators, right?
But you could also cancel 12 out with 4. But like you're saying, like first we go after the denominator.
Wait, when 12 after 4, you mean over here?
Yeah. You got 12.
Oh, you don't, not this 4. No, you can't do that.
Oh, because it's in front of it's the numerator.
It's in the numerator, that's right. 12, you're multiplying by it, so you can only cancel the denominator with it.
Oh, okay, thank you.
You're welcome. Good question. I'm glad actually someone asked that, so very good. Right. I've seen students in the past, what they would do is they would take this 12 and cancel it with something like this 4, or maybe with this 12, they would cancel it with this 2. You can't do that though, because we're multiplying it, you can only cancel with the denominator. Okay, so whoever asked that, great, that was, really good, thank you. Right, so this 4 cancels, but this 4 down here, this 4 though, we can cancel it with 12, and we get 3. Like so. Okay, on the right side here, right, 12 and 6, well, this 6 is gone, and this 12 becomes 2. Like so. Okay, good. All right, so that's canceling. Those denominators are gone. That's good. So now what we're going to have is the next equation below it. So we have 4 times x plus 4. So that's going to be another distribution, like so. 2x times 12, that gave us 24x, minus 3 from the 3 here. And we have this 2, so we distribute, like so. Come on. There we go. And now we actually get to multiply. So we have 4 times x, that's 4x. 4 times 4 is 16. The 24x, that was from the 12 times 2x. This 3 gave us this 3 here. And we multiply to get 6x plus 4. Let me just change the recording. Okay, so that's good. That's what we get here. All right. So now what we want to do is solve the equation at the bottom. 13x minus 16 equals 9x. Now, what's nice is it's not as bad as the other one. Okay, so we want to get x all alone. Okay, so here's what I did. I subtracted 13x from both sides, right? The negative 16 comes down. We have minus 16, which is really negative 16. Negative 16 equals negative 4x. Now, I personally like to have x on the left-hand side. So basically what I did here was I interchanged both sides. And that's something you can do. We get negative 4x equals negative 16. Okay, but we want x all alone. So we divide by negative 4. Doing so, okay, what we get is negative 4x over negative 4, equals negative 16 over negative 4. And that's x here equals 4. So 4 is our answer. 4 is our answer. Okay, so thank you for pointing out the mistake I made over here before. Are there any questions on this one? Okay, I think that. Okay, now I'm going to post a worksheet, although I did email it to everyone, but let me post it as well. That's not it. There it is. Okay, here, let me just share it now. There it is. Okay. See it? Oh, there it goes. Okay, good. Okay, so, it's just 3 problems. I figured it'd be good for practice. So, take about, like, what time is it? 12:20. I guess take like 5 minutes to do these 3. And if you need more time, I can give you more time. I mean, the first 2 should be pretty straightforward. For the third one, that takes a little more work, but it's not terrible. So I'm going to stop the recording. We'll take about 5 minutes. And I'm here if you have questions as well. So
we don't even need to find the LCM for the first 2, right?
You don't have to, no, because there's no fractions there.
Okay, thank you very much.
You're welcome. Good question. Okay, so let me stop the recording.